And hello all, Mr. Callen coming here for you with assignment for e-learning Monday, April 27th. Today our learning objective is going to be, I will convert very large and very small numbers between standard, that's normal, and scientific notation. So lesson description, learn how to represent numbers. Some people call me Mr. Callen, some people call me Uncle Tim, I'm the same guy. We're going to do the same thing with numbers here, standard normal notation and scientific notation. Going to be able to change back and forth from one to the other and understand why we do that. Now, all these materials, once again, are in Google Classroom. Found an introductory video. Somebody shared that with me. I wish I could give credit where credit is due. I got to find out who initially created that video. When I find out, I will let you know. Meanwhile, optional notes that you can read through on Khan Academy. Here is the guided practice video, and then you have some practice to do, as well as some exit problems in Google Classroom. So as you're going through your practice, a couple things. Number one, as highlighted in yellow, there are some answers. Yes, the answers are there to help you check your learning. Don't skip those problems just because the answers are there. Number two, as you're going through the assignment, think about those exit problems. You probably can figure out what's coming. How are all these problems similar? How are all these problems different? And then write yourself a step-by-step way of, turning a number into scientific notation. So think about that as we go along. Here we go. One thing that I'd like to mention, I said this before, I'm going to take a white pencil over here. I know some of you like to use the equation editor. I like to use the drawing and just write in with my stylus. I'm going to use white here at size 8, and I'm going to write out the answers. You might see the answers disappearing down the page. And then what I can do, you know what, it might be better to use a different color just to remind myself that eventually I should be able to erase that and figure out if my work is correct or not. Let's go ahead and make this a little larger now. You can see that my answers are whited out. Starting from the top, write each number in standard form. This might take you back to 7th grade math a little bit. So let's start with number 1. We're going to write that number in standard form. Now, the first thing that I think about when I think standard form is I need to understand, is this number really big or really small? So if I look here, I'm thinking big. I'm thinking, what is 10 times 10? Well, 10 to the second power, or 10 times itself, is 100. In other words, we have 9 hundreds. And yeah, I know we have some parts. We have those 3 parts as well. But the point of me doing that is now when I write down 9 3/100 times 10 to the second, if I know that's going to be big, that doesn't mean add 2 zeros. It means move the decimal point 2 places and make sure you move the decimal point so you make a large, large number. In other words, if I accidentally moved it the other direction, I would make a tiny, tiny decimal. That is not what we would want. So I can now rewrite this number as 903 with the decimal place in the proper place, and then I can erase my answer to check it. Again, the other way to think about it is if we have 9 point something, we could have some parts, times 10 to the second power, that literally means we have 9 hundreds. So if you check your answer, and yeah, we have some parts of $100 bills as well. If you look over here and check your answer, you see the 9 is in the hundreds place. And yes, we have those parts of dollars. In fact, we have 3 $1 bills. So a couple ways to think about that. Now at this point, I'd encourage you to pause and go to number 2, see if you can do number 2. As we return now, I'm going to go the other direction. Here, number 1, we started with scientific notation and went back to standard or normal form. Number 5 is going the opposite direction. We have the standard normal number, and we're going to write it in scientific form or scientific notation. Now, again, the first thing I ask myself, is this number big or tiny? And in this case, it is a large, large number. The reason I do that is because I'm going to first go ahead and copy down this number, noticing that I have 4 thousands, 400, 0, 10, 0, 1s. But scientific notation tells us to rewrite a number so that we have a decimal between 1 and 10 times some power of 10. Now, if I take a look here and ask myself, where could I put this decimal point? Well, if I put it right here, 44 is too big. If I put it to the left, 44 hundredths is too small. We need a decimal between 1 and 10. And if I write 4 wholes and 4 tenths, now there is a decimal between 1 and 10. But unfortunately, that's not where it goes. In other words, please don't tell me that 44 hundredths is the same as $4.40. What I can do is say, well, if I would take that and multiply it times 10 repeatedly and make a really big number, I move it 1, 2, 3 decimal places. Now I have a true statement. $4,400 is the same as 4.4 times 10 to the third power. And I'm going to go ahead and erase my answer, check it, and I see that that is correct. Let me think about it in a different way. I see 4 $1,000 bills. And yes, I know I have some parts, but just focus on the 4. In other words, 4 $1,000 bills is kind of like saying 4 something times 10 to the third. So that's just a different way to think about it. This literally means 4 thousands and some parts of thousands. Now, with that in mind, you might want to pause and go to do number 6, see how you do, and then come back to me. Now, let's be clear. These numbers are rather large numbers, and we actually had this as a 7th grade standard. Now let's crank it up a notch to an 8th grade standard, and you might immediately think to yourself, wait a second. That is nonsense, right? We've seen this before. All right, so directions. Write each number in standard normal form. So this is scientific notation. What the heck does 10 to the negative second mean? How do you multiply 10 times itself negative times? You don't. But what we do know and have remembered from the past is anytime you have a number in negative exponent form, you can flip it to its reciprocal and the negative exponent changes to a positive. In other words, this really means we have 5 and some parts hundredths. Now hold that thought, I'll come back to it. If we have 5.1 and we need to multiply it by 10 to the negative second, and that number is tiny, as we just saw, because a negative exponent changes to its reciprocal and becomes a positive exponent. If I need to make this into a tiny decimal, then I better move it 2 places, in this case, so that it makes a tiny decimal. I don't really think about to the left or to the right. I know Khan Academy and other people say go left, go right. I really want you understanding the number sense behind this. We really have a tiny portion of a dollar. Above we had huge amounts of dollar bills. Here we have a tiny portion. Erasing my answer, I want to check it, and it turns out to be true. So again, if I could review what's over here in purple, a negative exponent is ridiculous nonsense, but as soon as you flip it to its reciprocal, it turns into something that makes sense. In other words, we have 5 hundredths, and if you look, we do have 5 in the hundredths place. And yes, there is a part of a hundredth, in this case a thousandth, that would go beyond it. All right, with that in mind, feel free to pause and go to number 10, do number 10 on your own, check your answer. So again, we're cranking it up a notch with 8th grade, rewriting a number that was in scientific form in standard form. Now we're going to go the opposite direction, and we're going to rewrite something that's in standard form. We're going to write it in scientific notation. First thing I ask myself, is this number huge or tiny? And in this case, it is tiny. So if I were to rewrite this number we remember that to write a number in scientific notation, we need a decimal between 1 and 10 times some power of 10, but naturally, 84 is not a decimal between 1 and 10. So I ask myself, would 84 be, no, well, actually, you can kind of do this and then say, all right, which one of those works? 84 wholes wouldn't work, so you'd have to get rid of that. 84 hundredths, 0.84 wouldn't work, but 8.4 would. Again, though, you cannot tell me that this amount of money, literally 8 pennies, is the same as $8.40. So if we're going to move our decimal here, we have to be able to maintain that relationship and say, okay, move 2 times. Wait a second. It is not times 10 to the second power or hundreds. How about 10 to the negative second power or hundredths? Now, this is definitely a true statement. 84 thousandths is the same as 8.4 times 10 to the negative second power. Check my answer real quick. Another way to think about it is this 8 is in the hundredths place. Now, yes, I know there are parts, pieces, portions, but just focus on the 8 hundredths, which means we could write 8 hundredths, which means we could write 8 hundredths, which means we can write 8 hundredths. And yeah, there's a decimal and some other pieces. Pause for a second if you wish. Head to number 14, check your answer. So for today, we're going to have more practice to do with changing numbers between standard form and scientific form. 1 through 8 is actually 7th grade review. We cranked it up a notch, made a little tougher numbers, but that's huge, huge, huge numbers with positive exponents, powers of 10. On the other hand, 9 through 16, you'll notice are a little different in that they're tiny, tiny, tiny decimals, which is where the negative exponents come from. So take that. Let me know if you need any help, folks. I'm here to help you. Thank you so much.